It is the autumn of 1986, and on the roof of Reactor Number 4, a remote-controlled robot has stopped moving. Its circuits are burned out. The radiation up here kills electronics in under 2 minutes, and this machine was built to survive it. But the men sealing the worst nuclear accident in history had made a decision that still sounds insane. If the machines could not go up there, the men would. 3,828 of them, in shifts of 40 seconds. This is the story of the machines that built the tomb over Chernobyl. Those men were up there because of a problem no builder had ever faced. In the early hours of the 26th of April, 1986, Reactor Number 4 exploded during a botched safety test, and it did something a reactor is never supposed to do. It blew its own lid off. The heavy shield sitting on top of the core, a circular slab of concrete and steel weighing around 2,000 tons, was thrown upward and came to rest on its edge, leaving the Reactor Open to the sky. Graphite was burning. Nuclear fuel lay exposed, and a plume of radioactive smoke was climbing straight into the atmosphere, carrying more fallout than the bombs dropped on Hiroshima and Nagasaki combined. Within a day and a half, the nearby city of Pripyat, home to around 50,000 people, most of them the families of the plant workers, was emptied in a matter of hours and never lived in again. Around the plant, the authorities drew an exclusion zone 30 kilometers across and cleared it of people, a dead area the size of a small country, and at the center of it sat the one building nobody on Earth could approach. Here is the part that makes this a construction story, and not only a disaster. You cannot wall off something that no human being can stand next to. Every single solution to Chernobyl slammed into the same impossible fact. The most dangerous place on Earth had to be covered, sealed, and buried, and the radiation pouring off it would kill any person and destroy almost any machine long before the work was done. The engineers were fighting 3 fears at once: a graphite fire pumping radiation into the sky, a molten core that might burn its way down into the groundwater beneath the plant, and exposed fuel that could, in theory, come back to life. Before a single wall went up, 400 coal miners were rushed in from the Donbas to dig a 168-meter tunnel underneath the reactor, working in heat so extreme that many of them dug naked, just to slide a cooling slab beneath the core in case it melted down through the foundation. As it turned out, the core never did burn through, and the slab was never needed. But many of those miners had absorbed heavy doses of radiation for a floor that would sit unused, and a number of them died young because of it. And all of that was just to hold the line. The real structure had not even begun. We have built a lot of these stories on this channel. The machines behind the Hoover Dam, the derricks that raised the Empire State Building, the strange trick that carved Mount Rushmore. We have never built one where the machines themselves were the first to die. So subscribe and stay with us, because that is exactly where this goes. Sealing Chernobyl happened in 2 great waves, 30 years apart. First, a desperate tomb thrown up in 206 days by machines and men who were being poisoned as they worked. Then, decades later, the largest object ever moved across land, pushed slowly over the top of the wreckage. We are going to walk through both, machine by machine, starting with the ones they sent in first. The first machines into the fight were not bulldozers. They were helicopters. In the days after the explosion, the reactor was still an open furnace throwing radiation into the sky, and the only way to smother it was from directly above. So Soviet pilots flew out over the glowing core and dropped whatever might choke it. The air operation was run by General Nikolai Antoshkin, and at its peak, dozens of helicopters were in the air at once, cycling over the reactor one after another on a rhythm of roughly 2 minutes a run. Across roughly 1,800 flights, they poured about 5,000 tons of material into the mouth of the reactor. Of that, around 2,400 tons were lead, roughly 1,800 tons were sand and clay, about 800 tons were dolomite, and only around 40 tons were boron. But that boron mattered most of all because it was the part that soaked up the neutrons and kept the reaction from catching again. The heaviest lifting fell to the Meal helicopters, the Mi-6 and the enormous Mi-26, the largest helicopter ever put into production, and around 30 of those giant machines were used for radiation measurements and the most precise drops. And yet a great deal of what they dropped actually missed the narrow reactor opening and simply piled onto the surrounding roof. Some scientists have argued ever since that the bombardment did nearly as much harm as good, hammering the already broken building and stirring more radioactive dust into the air. But at the time, standing back and doing nothing was unthinkable. Flying these runs meant hovering, or very nearly hovering, directly over the most radioactive spot on the planet. Aiming was almost hopeless because the crews could not afford to linger for even a few seconds longer than they had to. They lined the floors of their cabins with sheets of lead and made their drops in fast forward passes, and many pilots flew mission after mission, absorbing doses that would end their flying careers, and in some cases, their lives. And on the 2nd of October, 1986, as the sealing effort was reaching its peak, one of these machines paid the full price. An Mi-8 helicopter moving in to make a drop clipped the cable of one of the tall construction cranes that had been brought in to build the tomb. The rotor blades shattered. The helicopter dropped out of the sky and slammed into the ground below, killing all 4 men on board. It is one of the cruelest details in the whole story. The cranes raising the tomb were the same cranes that knocked that helicopter out of the air. Their deaths were caught on film. On the ground, the plan was to keep human beings out of the very worst of it and let machines do the dying instead. The single most contaminated job of all was clearing the roof of the reactor hall, a place the workers grimly nicknamed the Roof of the World. The liquidators even gave its sections women's names: Masha, Katya, and Nina. And Nina, the zone closest to the vent stack, was the deadliest ground on the planet. It was littered with chunks of graphite and fuel that had been blown clean out of the core, some pieces so radioactive that standing beside them for a couple of minutes was a fatal dose. So the Soviets sent in robots. They built a remote-controlled machine called the STR-1, bolting a small bulldozer body onto the 6-wheeled chassis of a Lunokhod, the same running gear designed to crawl across the surface of the moon. The choice of a moon rover chassis was not an accident. That running gear had been built to keep working in the radiation and the vacuum of space, which made it one of the very few designs with any hope of surviving up there. It cleared something like 90 tons of radioactive debris and spared perhaps 1,000 men from ever setting foot on the roof. West Germany sent a remote demolition robot of its own. Other machines were dragged in to push and scrape at the contamination from a distance, including an amphibious remote-controlled Komatsu bulldozer that would end up abandoned and, to this day, sits too radioactive to move at a factory in the ghost city of Pripyat. Operators drove these machines by remote control, watching through cameras from behind thick shielding, trying to steer a bulldozer they could barely see across a roof that was killing it as it worked. But here is what the planners had underestimated. Radiation does not only poison people, it destroys electronics. The gamma fields on that roof were so brutal that they scrambled circuit boards and burned out motors in minutes. Machines built specifically for the job rolled up onto the roof, twitched, and died. And the dead robots were often simply left where they stopped, adding to the wreckage they had been sent to clear. And that left the men in charge with a decision that no modern army would ever be permitted to make. With the robots dead, the Soviet Union reached for the one machine it had in unlimited supply: people. The soldiers and reservists sent up onto that roof were given a bitterly ironic nickname: the bio-robots. The machines built to spare them had died on that roof, so the men were sent up to finish the job by hand. And the roof had to be cleared for a brutally practical reason. The new shelter's own roof was going to be built right up against it, and nobody could raise steel over a surface still covered in lumps of exposed reactor fuel. So the task fell to men, and it was simple to describe and almost unthinkable to carry out. Run out onto the roof, pick up a chunk of radioactive graphite or a piece of reactor fuel, haul it to the edge, and throw it back down into the ruined reactor where it belonged. Then run back inside. They did it in shifts measured in seconds. A man would sprint out under a stopwatch, work for his allotted time, and a signal would call him back, with each soldier ideally making only a single run in his life. Depending on the readings in a given spot, a man might get 40 seconds up there, sometimes 90, rarely more. They wrapped themselves in homemade armor cut from sheet lead, aprons and gloves and plates shaped to cover the chest and the groin, some of it weighing dozens of pounds, none of it able to stop the gamma radiation coming up through the roof beneath their boots. They were commanded by General Nikolai Tarakhanov, who climbed onto the roof himself, absorbed a punishing dose, and later collapsed. When the last debris was cleared, a Soviet flag was raised on the reactor's vent stack and filmed as a great victory. And more men were later sent up specifically to plant fresh flags when the radiation and weather shredded the first ones. In all, the records point to 3,828 of these men clearing that roof by hand, one desperate sprint at a time. Many of them carried the damage for the rest of their lives, and for their 40 seconds on the roof of the world, they received a certificate, a small payment, and, for some, a medal. Every stage of sealing Chernobyl carried the same terrible arithmetic. The machines could only get you so close. The last, most dangerous stretch was always closed by people. So when we talk about the tomb that went up next, remember that it was poured by men who knew exactly what the air around them was doing to their bodies. If that lands with you, subscribe, because this whole story deserves to be told as what it actually was: a construction project. That structure has a cold official name, the Shelter Object. The rest of the world knows it by another one, the Sarcophagus, and it was thrown up over the still-smoking reactor in just 206 days. To put that in perspective, a single modern skyscraper usually takes years to build. This tomb went up over a burning, radioactive reactor in a little over half a year. The job was handed to the most powerful builder the Soviet Union had, a secretive nuclear construction ministry and its dedicated site organization, known simply as US 605. Their minister, Efim Slavsky, was in his late 80s and personally drove the schedule, because Moscow wanted it finished fast. The task of judging whether the thing would even stand fell to engineers like Lev Bocharov, and every one of them was working against the same enemy, an invisible field of radiation that grew stronger the closer they pushed their men and their machines toward the core. Building the sarcophagus was less like a normal construction project and more like a military campaign. Tens of thousands of workers were rotated through the site, each man doing his small piece of the job until his allowed radiation dose ran out, at which point he was sent away and replaced by the next. No one could stay long enough to truly master the thing he was building. The knowledge had to be handed from one exhausted, irradiated crew to the next. Every man on the site carried a dosimeter, and the moment his badge said he had taken his limit, he was finished at Chernobyl, whether the job was done or not. Radiation was the one foreman on that site who could not be argued with. And it started with a problem most people never even think about. How do you drive a truck up to the most radioactive building on Earth without killing the driver? The answer was a machine almost nobody has heard of. The assignment landed at a truck plant in Ukraine on a Sunday evening in late June, and within weeks, under a lead designer named Viktor Kholyavko, engineers had taken a standard heavy dump truck and rebuilt the cab into a shielded capsule. They buried the driver in lead, 30 millimeters of it under the floor, because the worst radiation came up out of the contaminated ground. 25 millimeters in the walls, 12 millimeters overhead. The only window was a tiny slab of thick leaded glass, and the first several trucks rolled out with no side windows at all, because the special glass had not arrived yet. Clean, filtered air was pumped into the sealed cab, so the driver did not breathe the dust outside. And every capsule was tested for radiation leaks at a mining and processing plant before it was allowed anywhere near Chernobyl. The finished one-man capsule weighed over 3 tons on its own, and building the batch meant urgently shipping in around 60 tons of lead from Kazakhstan. Between the 10th and the 27th of July, 1986, they completed exactly 18 of these lead giants and sent them to the site. Even the vehicles had to be armored, just to get close. Then came the concrete, and the numbers here are staggering. More than 400,000 cubic meters of it were poured to raise the sarcophagus, along with over 7,000 tons of steel framing. By some accounts, the concrete figure was closer to 440,000 cubic meters. Either way, it was enough concrete to lay the foundations of a small city. But nobody could stand at the reactor and place it by hand. So the concrete was pumped in from a distance, through long booms that could reach out around 60 meters, worked from behind, shielding, so the men running them stayed as far from the reactor as the machine allowed. The German pump manufacturer Putzmeister sent 11 of its machines to Chernobyl for exactly this. Those pumps became so tied to this kind of work that decades later, the same company's machines would be sent to Japan to help cool the wrecked reactors at Fukushima. And even at Chernobyl, those pumps had a limit, because the radiation was so severe that if you brought them in too close, their engines faltered and the dosimeters reading the radiation went wild. There was a deeper fear underneath all of it, too. One of the leading physicists on site worried that the crews, blindly pumping concrete over scattered lumps of nuclear fuel they could not see, might accidentally be sealing up a giant atomic bomb. The whole shelter went up in 8 brutal stages, starting with clearing and concreting the ground around the reactor, then the outer walls, the walls dividing Unit 4 from its neighbor, a stepped cascade wall, a covering over the turbine hall, a towering buttress wall, the covering over the reactor compartment itself, and finally the ventilation. Lifting the giant steel elements into place fell to towering cranes, including huge machines from the German manufacturer Demag. And these cranes were the true bottleneck of the entire project. They ran around the clock, 24 hours a day, and they were in such relentless demand that when scientists asked to borrow one for a few hours to lower instruments onto the roof, they were turned down, because the cranes could not be spared from building the tomb. The most exposed pieces, like the segments of the giant buttress wall, were built off-site and lowered into position by a remotely operated tower crane, so that no human hand had to be there. And across the top, over the shattered reactor hall itself, they laid enormous steel beams, the largest of them nicknamed the Mammoth Beam, and another the Octopus, and roofed the whole thing over with pipes and steel panels. The stepped, cascading shape of the walls had a hard practical logic. It let the crews build upward and outward in layers, keeping the men and the cranes as far back from the open reactor as the design would allow. And here is the part that decided everything that followed. the sarcophagus was built too fast and under conditions far too deadly to ever be built properly. Because of the radiation, workers often could not get close enough to weld or bolt the pieces together at all. Sections were simply lowered until they leaned against one another. One engineer who later worked on its replacement described it bluntly, saying it had been put together like a house of cards, with no welded or bolted joints, so that it would not take much of an earthquake to knock it down. When the structure was declared finished, there were still more than 1,000 square meters of gaps and openings across the roof. It rested, in part, on the ruined and unstable remains of the reactor building itself. By the time it was closed, this tomb had sealed in something like 740,000 cubic meters of contaminated debris, equipment, and soil, along with the wreckage of the reactor and the fuel still burning away inside it. The document formally commissioning it was signed at the very end of November 1986, barely 7 months after the explosion. It was an astonishing feat of speed and sacrifice, and almost everyone involved knew that it was temporary. Somewhere beneath all of that concrete, the story had left behind its most infamous object. When the core melted, part of it flowed down through the building like lava and hardened into a black, glassy mass of fuel and sand and metal that came to be called the elephant's foot. It was so radioactive that when investigators finally reached it, years later, they could not stand in front of it to take a photograph. They had to use a mirror around a corner because a few minutes of direct exposure would have been lethal. Decades on, it has cooled and cracked, but even now, lingering too close to it is dangerous. That was the thing the sarcophagus was built to contain. That was what all the concrete and all the sacrifice was wrapped around. It is worth pausing here on the human cost, because it is genuinely hard to pin down, and anyone who hands you a single clean number is guessing. The first to die were the firefighters and plant workers who fought the blaze on the opening night, many of them with no idea that the smoke pouring off the reactor was lethally radioactive. The official immediate death toll from the accident was 31, and most of those men were gone within weeks, from doses that no hospital on Earth could treat. But hundreds of thousands of liquidators cycled through the wider cleanup after them, by some counts as many as 600,000 people, and a real share of them absorbed heavy doses of radiation. Untangling exactly how many did specifically because of the shelter construction, as opposed to the fire, the evacuation, or the long years that followed, is something the records simply will not let us do cleanly. What is not in any doubt is that this tomb was poured by people who were being harmed as they poured it. Just how temporary the sarcophagus was became clear quickly. Within a couple of years, in December of 1988, Soviet scientists were openly admitting that it would last only 20 to 30 years before it needed serious work. And the trouble was not simply age. Rain got in through those roof gaps, and water trickling down through a structure packed with nuclear fuel is a nightmare on every level, feeding corrosion and threatening to wake a chain reaction deep inside the wreckage. Dust laced with radioactive particles piled up in the dark. The steel rusted. The whole improvised tomb was slowly sagging under its own weight. The danger was not theoretical. In February of 2013, a section of roof and wall around 600 square meters in size collapsed in the turbine hall right beside the sarcophagus, and 225 workers had to be pulled out and the site evacuated. By then, engineers had already been forced to build a separate steel framework, more than 60 meters tall, leaning hard against the shelter for the sole purpose of stopping it from falling down. Everyone understood that this was a stopgap. Chernobyl did not need another patch. It needed something that could pass right over the top of the entire failing tomb and seal it away for a century. If you have made it this far with us, you already understand why what came next had to be so enormous. Stay with us, because this is the payoff. It is called the new Safe Confinement, and almost every number attached to it sounds invented. It is an arch of steel large enough to swallow the entire ruined reactor and its sarcophagus whole. It stands 108 meters tall, roughly the height of a 30-story building, tall enough on the inside to house the Statue of Liberty. It spans 257 meters, wide enough to cover a stadium. It runs 162 meters from end to end, and fully fitted out, it weighs around 36,000 tons, several times the weight of the Eiffel Tower. It sits on a foundation of around 400 piles, driven deep into the ground. It is wrapped in around 86,000 square meters of insulated steel paneling, and it is designed to last for at least 100 years. It is the largest movable structure ever built on land. Nothing bigger has ever been made to move. It was raised by an international team, a French-led consortium named Novarca, formed by the construction giants Vinci and Bouygues, and paid for by dozens of nations through a special fund managed by the European Bank for Reconstruction and Development. Around 45 countries and institutions put money in. The world helped pay because the disaster had never respected borders. The fallout from Chernobyl had drifted clear across Europe in 1986, and no single country was ever going to shoulder the cost of sealing it alone. The arch alone cost around 1.5 billion euros, and the wider effort to make Chernobyl safe ran to more than 2 billion, with the bank itself putting in around 700 million euros of its own. But building something this size was only part of the challenge. The same enemy that had haunted every stage of this story for 30 years was still waiting on that spot: the radiation. They did not build the arch over the reactor. They could not. The radiation there was still far too high to keep thousands of workers standing on that exact spot for years on end. So instead, they built it off to the side. A few hundred meters away, on cleaner ground, they cleared a vast assembly yard and put the arch together there, where the men could work in far lower radiation. Work on the site began around 2010. The arch itself was assembled from 2012, and it went up in 2 halves. More than 1,000 workers were on the project, housed in the old town of Chernobyl, and cycled carefully to manage their exposure. Each half of the arch was raised in 3 great lifts, jacked upward section by section, and then the 2 giant halves were bolted together, in 2015, into a single unbroken arch. Assembling and lifting a structure this size, and then moving it, had never been attempted anywhere before. There was no textbook for it. Every stage had to be worked out from scratch. Then came the part that still looks impossible on film. They slid it. This 36,000-ton arch was lifted onto a set of rails and pushed sideways across the ground toward the reactor. The whole structure rode on a purpose-built skidding system, gliding on low-friction Teflon pads, driven by a bank of 224 hydraulic jacks that shoved the arch forward roughly 60 centimeters with every single stroke. Push, reset, push again, across a distance of 327 meters. The move began on the 14th of November, 2016, and finished on the 27th, with the sliding spread over several days and only around 40 hours of actual movement. Engineers watched it the entire way, because a structure that size could not be allowed to twist or jam as it moved, and a single bad stroke across 300 meters could have been a disaster. Meter by meter, the biggest object ever shifted across land crept over the top of the old sarcophagus and closed the wound at the center of Chernobyl. When it settled into place, the ruined reactor that had defeated robots, poisoned thousands, and dictated 30 years of desperate engineering was, at last, sitting under a roof built to shrug off a century of Ukrainian winters, storms, and even an earthquake. And this is where the story quietly turns from burial into demolition. The new safe confinement is not simply a lid. Built into its ceiling are two enormous remotely operated cranes, each able to lift around 50 tons and running the length of the arch on tracks fixed to the roof, along with workshops and remote tools to cut up, decontaminate, and pack away radioactive pieces as they come down. They are designed to reach into the old, crumbling sarcophagus and take it apart from the inside, without ever exposing a single human being to what lies beneath. Sealed inside its own controlled atmosphere, with the air held at a slightly lower pressure than outside so that contamination cannot leak out, the arch buys the world the one thing Chernobyl has always demanded: time. In July of 2019, the finished structure was formally handed over to Ukraine to operate. The plan is to spend the coming decades using those internal cranes to dismantle the old shelter piece by piece and pull out the fuel-bearing material, the most dangerous long-term task of all, and the whole reason the arch had to be built to last. Sensors watch the reactor around the clock from inside the shell, listening for any sign that the fuel deep in the wreckage is stirring. 33 years after the explosion, the machines had finally won. So what became of all the machines that fought this thing? Most of them could never come home. The helicopters, the trucks, the robots, the bulldozers, all of it drank up so much radiation that it turned into waste in its own right. Fleets of contaminated vehicles were driven out into the exclusion zone and simply left, buried or lined up in open fields to rot. That remote-controlled komatsu still sits in Pripyat. Many of the trucks and diggers were hauled to a disposal site called Buryakivka, where rows of contaminated machines were logged and numbered, in some records past 390, and buried in the earth. And over the years, scavengers cut into these graveyards for the valuable metal until Ukrainian security services were making arrests and seizing radioactive scrap that had been smuggled out and sold. You have probably seen the photos of these graveyards and heard that thousands of abandoned vehicles are still parked out there in a field called Rosoka. It is worth being honest about that. The most famous of those graveyards has, in fact, largely been cleared. Satellite images show it sitting empty for well over a decade, its contents cut up and carried off. There was nothing mysterious about it. Almost everything at Chernobyl was dealt with this way in the end, quietly and out of sight. The cost of all this reached far beyond the dead and the injured. The effort drained a staggering amount of money and manpower from a Soviet Union that could least afford it. And Mikhail Gorbachev himself later suggested that Chernobyl, more than almost anything else, may have been the real beginning of the end of the Soviet state. And that is the strange truth of this place. The explosion itself was over in seconds, but the work of cleaning it up has run for more than a lifetime, and even now it is not done. The new safe confinement is rated for around 100 years, but the fuel it covers will stay lethal for far, far longer than that, which means that somewhere down the line, long after everyone who built that arch is gone, someone will have to solve this problem all over again. Chernobyl was never truly sealed. It was handed forward, and every machine in this story, from the first helicopter to the greatest moving structure ever built on land, only ever bought us time. If you want to see how the impossible actually gets built, the machines, the men, and the price, this is the channel for that, and we will see you in the next one.